Hello, everyone. Welcome back to Tech Talk Live. Today's topic is Kyverno, what, why, and how. All right. Today we have a guest speaker, Anusha Hegde from Nirmarta. Anusha, over to you.
Hey everyone, good morning, good afternoon, and good evening. I'm Anusha. I'm a technical product manager at Nirmarta. I joined about 5 months ago, and ever since then, I've been working on the enterprise side of things. Nirmarta is the company behind Kyverno. So I take care of enterprise Kyverno and SaaS offerings around Kyverno. So our talk today would be around the basics of why we need, even before Kyverno, why we need admission controllers and how Kyverno can help address a lot of security issues that are there. Cool. So let's get started. So the agenda for today is we'll go through some of the real world problems with Kubernetes configurations. We'll walk through like different examples, and then we'll see how policy management can help address these issues. And we'll go through how Kyverno fit into all of this. We talk about Kubernetes configurations, policy management, but what about Kyverno? And we'll go through what are just admission controllers in Kubernetes and how Kyverno essentially is an admission controller, and some of the Kyverno use cases that you can start using right away after this talk today. And there'll be a quick demo on how you can use Kyverno in your environments. So these are some of the real world scenarios. Let's start with validating Kubernetes configurations. So even before getting to this, I'm sure all of you are aware of just bringing up a Kubernetes cluster. You must have done something like kind create cluster. You could have used Minikube or even used cloud provider managed services like EKS. So these tools are great in the sense that they help you to bring up a Kubernetes cluster within minutes. But if you had to do it yourself, because Kubernetes involves a lot of components, you'd be juggling through different configurations, and it's hard to bring up a cluster. But these tools provide an abstraction so that you can get something out of the box quickly and start working with it. But that also means these tools assume some set of default configurations, and these default configurations need not always be secure. So while it is great for you to get started with, use it as a test cluster, it is not very great to use the same set of default configurations in a production environment. That is where you start tweaking some of these configurations, trying with the intention of making your environment secure. But like Kubernetes involves a lot of moving components, it gives you a lot of flexibility as to what configurations you can change. And with a lot of flexibility also comes a lot of opportunities to misconfigure this. So there must be some way to validate that whatever configurations you're setting is actually secure and not opening any backdoors for any security threats. Then secondly, we have pod security. So Kubernetes recommends certain pod security standards. There are different profiles like baseline and I forget the name. So there are different profiles where Kubernetes recommends this is how you should run your production clusters in. And we have managing namespace and workload security. Suppose, say, you're a platform team and you manage, say, a centralized cluster. You are responsible for catering to the needs of different developers and teams in your organization. Whenever someone requests for a new namespace, you as a platform team admin or a platform engineer, you're responsible for creating a new namespace and making sure the workloads that are run in that namespace are secure. You probably also want to, say, label some of these namespaces, like, say, a finance department comes in and they ask me, give me a namespace. Me as an admin, I have to make sure I label those namespaces correctly so that when I have to, for example, identify what is the AWS cost that is, incurred throughout my clusters, I can segregate them namespace wise. These are some of the operations tasks that I'll have to do. So not only just providing a new namespace, you have to do all of these default configurations, generating new, say, access controls, because you also have to apply fine-grained access controls. In the sense, two different teams need not know what's going on in each other's namespaces. They are given a namespace and they are supposed to work within that namespace. So, but you as an admin are responsible for creating these roles, role bindings, and all other RBAC controls for all of your teams. So all of these require dealing with configurations day in and day out. And that's why there's a lot of scope for you to say even miss one configuration, and that one configuration can lead to security incidents. So let's move on and acknowledge what is the underlying problem in all of this. In the previous slide, we spoke too much about configurations. And it is true that one of the major security problems are caused by Kubernetes misconfigurations. Just because there are so many of them, it is easy to get something wrong. And it's often enough for just one misconfiguration to cause a security incident. And some of them could be environment specific, but some of them may not be developer concerns, but critical for operations. So you as an admin may be responsible for making sure your AWS costs are not crossing some threshold, but a developer trying to deploy some application need not worry about that. Instead, the developer should be ensured that there are guardrails in place that will not exceed certain cost or will not exceed certain security violations. But we also have external configuration management tools like Helm and Customize. So these tools are great when you have to install something or upgrade or delete a particular application. But these cannot ensure that the configurations that you install applications with always follow best practices. So yeah, these are some of the problems, but the underlying problem across all of them are Kubernetes misconfigurations. So now that we know what the problem is, so what is the solution? So thinking a little outside the context of Kubernetes, right? Let's get into an everyday scenario. Suppose say you're driving a car. So you cannot just drive however and wherever you want. There are some rules in place. Something like I have to drive on the left side of the road or right side of the road, depending on which country you're driving in. There could be rules around there's no free left turn or there's no free right turn. And things like you have to stop at a red signal. You can move when the signal is green. So there are some rules and regulations in place so that you are so that there are no accidents, nobody is harmed due to a rash driving. Similarly, but having just rules and regulations is not enough. There should be some entity that can enforce these rules and regulations. So if somebody says there's a rule I cannot drive on the left, I will obviously think, okay, what if I drive on the right? But if somebody tells me, okay, you're going to get a ticket for it, then probably I'll be more concerned and say, okay, let me drive on the left, right? So there should be some entity that says that is going to enforce all these rules and regulations. Sometimes, say you're let off with a warning, it might not be that critical of a violation, but sometimes you get pulled over and you get a ticket, which means you have violated something critical rule in the system. So this is nothing but policy management, right? So there's a set of rules and there's an entity that's governing all these rules. So this is nothing but policy management. And coming back to the Kubernetes world, we have policy management here as well. So in Kubernetes, the policy management or an entity that enforces all these policies can be achieved via admission controllers, because admission controllers sit in the critical path of your API request. We'll see in the later slide where exactly it fits into that request path, but Kubernetes admission controllers provide a way to inspect or validate so that any incoming request, you can see what the request is trying to do. Is it trying to violate some rule? You could either block the request saying, no, this is violating a critical rule, or you could just let it pass and warn or, raise an audit log saying something, this object is violating something, but it maybe is not of high criticality. So there are general purpose policy managers. Because policy management is not a new concept only to Kubernetes, there are general purpose policy managers that are not specific to Kubernetes, but in general. Open Policy Agent is one such example, of which Gatekeeper is a particular implementation for Kubernetes. But since these are general purpose and not Kubernetes native, they often require you to learn some language, some new language, like Rego in the case of Open Policy Agent. Because you have to programmatically enforce these rules, you'll obviously need some kind of a language. Next, you may say that, I'll write my own admission controller, which is still fair. Nobody is stopping you to write from an admission controller, but it's not a very trivial use case. There are popular policy engines like Kyverno and Gatekeeper. There could be others that I'm not aware of, but it's usually you concentrate on your business logic while delegate all the policy management to the policy engines that are out there. So this is about policy management. So let's come to Kyverno. So what is Kyverno? It's a policy engine designed for Kubernetes. So when I say it is for Kubernetes or it is Kubernetes native, it means that it uses all the Kubernetes resources, patterns, and EDMs. So if you're familiar with, say, writing a deployment or writing a pod spec, it should be fairly easy for you to pick up writing a Kyverno policy, because these policies are written in YAML format. It is Kubernetes native, and it follows all the Kubernetes resources. Like it defines a resource for policy, for cluster policy. There are policy results, and so on. The word Kyverno itself comes from a Greek word, which means govern. I think it rightly fits because Kyverno sorts of governs your cluster for all the best practices and warns you for anything that is violating any policies. Although I have heard multiple pronunciations of it, two of them being Kyverno and Kyverno. I've heard the maintainers say Kyverno, so I'm going to stick with Kyverno, but feel free to choose. Okay, so why Kyverno? Again, they are declarative policies. Everything in Kubernetes is declarative. You write a YAML spec. You have a spec that says this is my desired state, and you have controllers that are going to continuously reconcile your current state of the system to the desired state. So Kyverno is Kubernetes native. You write declarative policies, and because they are in YAML, they're so simple to write and easy to manage as well. Towards the end, we'll look at a sample policy and see how easy it is to actually write it. Policy results are easy to view and process as well. So what happens when some resource violates a policy or a rule? A policy result is generated, and the policy results themselves are custom resources. So it is same as how you deal with any other resource. You can do kubectl get policy report, and then you can view the results. You can, with Kyverno, you can validate, mutate, generate, and verify images. So there are four main rules. So validate comes in two modes, audit and enforce. Audit means you're just creating an audit log or you're generating a warning message, but you're not going to block the request even if it is violating some rule. Whereas enforce means you know the rule, the policy or the rule, the severity is so high that you don't want any resource to violate that particular policy. So if you set it in enforce mode, your admission request is going to get rejected. And then you have mutate. Mutate, as the name suggests, mutates resource. So whenever there's an incoming resource and you see that a proper label is not applied, Kyverno lets you to mutate those fields and add the label yourself. And then you have generate. In case of generate, like the namespace use case that we discussed, if I'm creating a new namespace for a new team, I'm going to generate some other resources also. I'm going to generate, say, some network ingress. I'm going to generate role binding. So these are all additional Kubernetes resources that I'm generating on the fly. And then we have verify images. This is, again, an advanced feature wherein currently Kyverno supports cosign. There are plans to support Notary V2 as well. So if you sign your container images using cosign today, when your image is being deployed in the cluster, you can write Kyverno policies to make sure that the image that you have signed the private key with matches the public key. So you can write verify image policies. You can also verify attestations, not just container images. And Kyverno supports all Kubernetes resource types, including custom resources. And it adopts all Kubernetes patterns and practices. That is, you can write labels and selectors, you can set owner references, and so on. All right. So let's understand admission controls in brief. So whenever an API request comes in, it goes to the API HTTP handler. The first thing that happens is authentication and authorization. So once this part is done, that is where it goes to the mutating admission webhook. So there are two kinds of admission controllers. One is mutating admission control, and the other is validating admission control. The order of processing is always mutating first, validating second. These admission controls are nothing but webhooks. You can configure webhooks and you can actually register your webhooks with your API server. So as soon as the authentication and authorization is done, the API server looks for any registered webhooks. And of all the registered webhooks, the mutating ones are called first. After your webhook is processed, and since you can mutate resource here, there's obviously going to be a schema validation. And once you pass the schema validation, if there are any webhooks, any validating admission webhooks that are registered, those are called. So here, if the admission webhook accepts the request, your request can go ahead and get persisted to etcd. But in any case, if you're violating any policy or if you're violating any conditions, the validating admission controller can block the request. That is where your request gets rejected and nothing gets stored to etcd. So from this image, it's clear, I think, that all we need is a webhook, two kinds of webhook, mutating and validating. But now let's see how Kyverno fits into this. This is probably the same diagram. Like if you look at the top line, it is the same sequence. You have API request, handler, authentication, authorization, mutating, schema validation, validating, and then etcd. All that is changed in this slide is the webhook part. And that's what Kyverno is. So Kyverno provides you that mutating and validating admission controls, but it's a lot more powerful than that. There's a powerful Kyverno engine that can do a lot of things. Like we said, Kyverno is Kubernetes-native. It follows all Kubernetes patterns. So there are a lot of controllers that are there. So there's a webhook controller that configures the webhook itself. There are report controllers that take care of the admission reports. There are background scan reports, and there's a background controller. So background controller is, suppose say you have already created resources in your cluster and you install and you deploy Kyverno later on. So there could be some resources in your cluster that should not have been there, that are violating the policy, but at the time you did not install or deploy Kyverno into your cluster. So there's a background scan field in your policies that you can set to true. It means it will go and scan for all the resources and still report if there's something violating in the cluster and it should not have been there. It's not going to remove that, but it's just going to warn you in terms of reports. So compared to the previous slide, all that is changed is the webhook part, and Kyverno is replacing that part. So if you want to read about in depth on how this works, I have linked the actual documentation on how Kyverno works. Feel free to take a look. And now this is the anatomy of a Kyverno policy. This is fairly simple. So a given policy can have one or more rules. So we have a rule set. So you can have one or more rules. Each rule can say it can match or exclude. And I say match. It can match on all of these different types. It can match on kinds. It can match on names, annotations, so on. Similarly, it can exclude on all these types. A typical example for this is to say match on all namespaces, but exclude namespace XYZ. So these are the two different types. And then there are four major rule types, that is validate, mutate, generate, verify. We just discussed this a little bit earlier. And in the demo today, we are extensively talking about validate. Mutate and generate are almost along the similar lines. I think documentation should be good enough to get you going there. And verify images is slightly advanced concept, which will be explained in a so next week we have another webinar, so we are going to cover it there. But this, I think, should be fairly straightforward. A policy can have one or more rules with match or exclude blocks, and then 4 different types of rules. All right. So given a policy structure. Okay, let's map to this particular policy. Here we say it's a cluster policy. So there are 2 types, policy and cluster policies. Policy means it is namespace scoped. A cluster policy is throughout your cluster. It is similar to saying role and cluster role. Then this is the validation failure action. So this is the different mode I was talking about. You can have the validation failure action to be in either audit mode or enforce mode. If it is in audit mode, if any incoming request is violating this particular rule, it is only going to log that violation. But if it is set in enforce mode, and if an incoming request violates this rule, the request is going to get rejected. It's saying background true. It means once you install this policy, if there are already existing resources that are violating in your cluster, it is just going to scan for all of them and set it and report those resources. So we covered a cluster policy, what is validation failure action, and the background fields. Next, we come to the rules. So rules, like I said, you can have one or more. So it is a list here. You can have as many rules as possible. So here we have the validate image tag, and we say we are matched. We are using the match block. We are not using exclude here. So we're saying match on resource of kind pod. So it means any request that comes in, any API request that is for the kind pod is validated against this policy. If say a new service comes up or a new some other resource comes up, that is not violated because this particular policy is only for the kind pod. Then we are using the rule type validate. Again, going back, there are 4 types: validate, mutate, generate, and verify images. Here we are talking about validate. This is a nice message that is going to get displayed if there is any violation, so that this message actually can help you debug as to what's going on, as in why certain resource or API request failed, and you can take necessary actions. So here it is saying using a mutable image tag latest is not allowed. And that's good because you should almost never use latest in your production environments. So here, the pattern itself. So what is it validating against? It says in the spec container, in your pod spec, you have the containers field and that has an image, and you say it should not be equal to latest. So *latest is saying whatever could be your, say it could be coming from GCR or it could be coming from a GitHub repo, whatever be the path, whatever be the domain, the final tag should not be latest. So here we're just saying star, but you can write very complicated regex in Kyverno. But for this example, star is enough. And we're saying not equal to. So we are all familiar with such operators of not equal to, greater than, less than. So Kyverno supports those operators. So looking at this policy, this is a plain YAML file. This is hardly 20 lines. So within 20 lines, we are actually securing our cluster from images that have the latest tag to be deployed. Here we are only auditing, but we had enforced, we can say, in a cluster where this policy is deployed, no container images with latest tag are going to be deployed, all within 20 lines. And that's why, Kyverno is so simple to use and get started with. Yeah. Moving on. Yeah, so this is what we saw earlier. We have different patterns, like star means 0 or more. That's like a common convention. Question mark is any one. So here we are saying if there is at least some text present for the app label. It also supports different kinds of operators. Yeah, so it's pretty easy to write a Kyverno policy. You can write as simple to as complicated using a different combination of these patterns and operators. Now there are sample best practice configuration checks. There are actually a lot more. I have linked to the Kyverno policies repo in the end. So Kyverno has over 250 policies that are already present. These are out there in the community, mostly contributed by the Kyverno contributors, but also by the community. Um, so some of them are configuring readiness and liveness groups. You need to have readiness and liveness groups configured for your pods. You have to specify resource quotas. This is especially when you're a central cluster admin and you're giving out namespaces to different departments. You need to define quotas. Uh, the third one is what we just saw. Do not use latest image tags. That's not a good practice. You can restrict certain image registries if you are running, say, in an air-gapped environment and you want to make sure all of your images are deployed from your private registry XYZ. You can write policies for that. And then you can configure pod security. So there are, like I said, Kubernetes itself recommends baseline and restricted pod security standards. So you could configure that using Kyverno. These are some of the sample ones that I've listed here, but there's a long list of best practice configuration checks in the repository. Moving on, some of the use cases, obviously pod security standards and any additional security validation and enforcement you want apart from the pod security standards, like the latest image that we saw. It could be fine-grained RBAC. You can say system unauthenticated group should not be bound to any other cluster role or binding. So, and then there's multi-tenancy ones, wherein whenever you generate a new namespace, you also generate more resources. You can auto-label, that is, you can mutate incoming requests. You can also do things like including certificate injection, wherein you can define mounts and you can make sure you are injecting certificates into your pod volumes. So these are, again, some of the subset of use cases that I've listed here, but the repo should give you the breadth and depth of Kyverno. Yeah. And yeah, talking about policy reports, we saw how you can write a Kyverno policy and what are the different ways you can either audit it or enforce it. But what happens? How do you look at a violation? So again, POL-R stands for policy report. It's a Kubernetes custom resource. So it is, you can use kubectl to get policy report. You can describe policy report. You can make it output in the form of JSON. Because it's a custom resource, it is very easy to deal with. You can see you get a nice result of how many policies and rules passed, failed, if there's a warn, and so on. Okay, let's look at a quick demo. All right, so I have an EKS cluster here with 2 nodes. So what we're going to see is we will first try to run a pod that is violating certain best practices without installing any policy. We will see that how easy it is to let any pod run, but then we will install all the good practices and then see how that particular pod is being blocked. Before that, I want to show you that Kyverno itself I've installed in this cluster. So Kyverno is running in the Kyverno namespace, and cpol is cluster policies. So again, Kyverno is all Kubernetes native. You can use kubectl get cpol. Now I'm going to run a pod. I'm going to call it root. So here it is violating a lot of things. It says privilege true should, it's saying privilege should be true, but one of the standard recommendation is you should not allow the containers to get privileged access. It is trying to use an image that is saying Alpine latest. You should not be doing that. Yeah, so let's see what happens if I do this kubectl run. That's it. My pod is running and I'm inside the container as root. So we don't want this. So how do we actually stop this from happening? If I was a bad actor and if I could get into the container as a root, I could probably bring down the node or the entire cluster itself. That's where Kyverno comes to rescue. So like I said, there's There's a whole bunch of policies in our GitHub repo. And what I'm doing here is I'm enforcing the pod security standard policies in enforce mode. Enforce means we will not allow a bad request to go through. And another good thing is the policies that are there in this repo, you could install them via Helm as well. And Kyverno itself is available as a Helm chart. So you can very easily integrate your Kyverno install with any of your GitOps pipelines so that they can install it as a Helm chart. So now I've installed a bunch of policies here. Let's quickly check. So yes, all of these policies are in ready state now. Now let's see what happens if I try to execute the same command. Okay, so there's a bunch of errors. So it says admission webhook denied the request, which is a good thing. We did not want this pod running in our cluster, but it also tells us what are all the rules and policies that failed. It says require drop all, containers must drop all capabilities. It says some setting is missing or you're given some privileged access and so on. So this was a basic example of how you can use Kyverno to just, block bad pod from running. And this is just in a dev environment, right? But imagine this at a production scale wherein you have lots of nodes and pods that are running. You would want security measures in place. So this was the short demo that I had. So what we saw today was a very basic feature of Kyverno, but yet very powerful and widely used. So if you're starting with Kyverno, I'd suggest you start with the validate policy and the pod security standards. Next, there are a lot of advanced features, like you can define variables in your policy. You can do external data lookups. You can actually make API calls. You can verify image signatures and attestations. And there's also a command line. So there's a Kyverno CLI that's actually very helpful if you're authoring policies. You don't need to have a running cluster. You don't need to even install Kyverno anywhere. All you need is the Kyverno CLI. You point to it, the policy that you're writing or authoring, and a resource YAML. So it can apply that policy against the resource and tell you what's wrong, or if there's something wrong with your policy, you can immediately reiterate and write a better policy. And the CLI can also be used in CI/CD pipelines. Like if you are configuring GitHub actions, it is a good practice to validate all of your resource manifests against a set of standards. Again, you don't need a running cluster. You can just use the Kyverno CLI. And Kyverno 1.9 was released just a few weeks ago, and there are a ton of new features introduced. I'd highly recommend going over to the release blog once you are familiar with the basics of Kyverno. And we will talk about in depth of all the cool features that's come in 1.9 in our next webinar. And yeah, I want to take a minute to talk about the Nirmarta Policy Manager. So like I said, I'm a product manager for the enterprise Kyverno and all the enterprise offerings around Kyverno. So the screenshot is from our SaaS offering, which we call the Nirmarta Policy Manager. So this dashboard gives you a high-level overview of what's going on in your cluster. You can see what policies are failing, what are the violations by categories, violations by EKS best practices, pod security standards, and so on, by namespaces. We also provide continuous compliance. We support standard compliance like CIS, NIST, and we also have inbuilt compliance like RBAC compliance, multi-tenancy best practice compliance, and so on. And then policy reports themselves. If something failed or something passed, you can dig into a policy report, see what exactly failed, what cluster it belongs to, what namespace it belongs to, and so on. And there are like a lot of third-party integrations as well. So if you're interested, head over to this link and there's a free trial available. Do give it a try. All right. Time for summary. So what did we learn today? So we know that Kubernetes misconfigurations are the major cause for most of the security incidents that are happening. And policies are a useful way in mitigating those misconfiguration issues. Kyverno is a policy engine that is built for Kubernetes. That is, it is Kubernetes-native. Kyverno can validate, mutate, generate, and verify images. There are several different standards available, like there's workload security best practice, there's pod security, there's supply chain security, and so on. And Kyverno is easy to use. We all saw the 20-line YAML file wherein we could audit our cluster for containers running with latest image tag. So it is easy to use. So do install Kyverno in your clusters, try out the best practice policies, and definitely give us feedback. Also, I highly recommend going through this blog. It's the 2-minute Kubernetes test. So here we talk about how you can scan your cluster using the Kyverno CLI against pod security standard practices. Within 2 minutes, you get a list of everything that's wrong with your cluster and how you can improve that. So yeah, and there are some additional resources. You can go through the documentation. Our documentation is extensive. I missed to link the Slack channel. I'll do that later. So we are very active in the Kubernetes community. We have a channel called Kyverno. We are also on the CNCF Slack. So do reach out to us if you face any issues or if you have any feedback in general. And the policies repo itself, there are over 250 policies. So if you're just getting started, there's definitely your policy should be amongst one of those 250 and you can get started within no time.
Awesome. Yes. Before we wrap up, our next TikTok Live will also be on Kyverno, and we'll take a deep dive this time with Chip, who is the maintainer of Kyverno. It's going to be on February 21st. So even if the time doesn't suit you, please do sign up. Then we will send you the recording once the live session is finished. We have quite a lot of other sessions lined up already. So please visit our website at mirantis.com/labs and sign up for them. All right, that's all we've got today. Thank you again for joining Tech Talk Live, and I hope to see you soon again in 2 weeks. And thank you.